So we are taking now the problem number 26 in the unit 2, right? That is the module 2, problem number 26. The zero mean bivariate random variable x1, x2 have following variances: variance of x1 and variance of x2, then correlation coefficient of them. Then we have two random variables y1, y2, which are obtained with this formula. We need to find the variance of y1, y2, and the covariance of y1, y2. So first covariance of x1, x2 is nothing but the correlation coefficient of x1, x2, which is 0.8, the standard deviation of x1, which is root of 2, standard deviation of x2, which is root of 4, and that will give us this, and that will be this. Then the variance of the what you call y1 is nothing but 3 square variance of x1 plus 4 square variance of x2 plus 2 into 3 into 4 into covariance of x1, x2. So first he has written here, 3 square variance of x1 plus 2 into 3 into 4 into covariance of x1, x2 plus 4 square into variance of x2, and that will give us this. Similarly, sigma y2 square, that is the variance of y2, will be minus 1 square into variance of x1, that is 2 itself, then 2 into minus 1 into 2 into covariance of x1, x2, and that is what is written here. Then 2 square into variance of x2, that is written here, and we'll get this. Then covariance of y1, y2 will be 3 into minus 1 into the variance of x1, then 3 into 2 plus 4 into minus 1 into covariance of x1, x2, then 4 into 2 into the variance of x2, and that is what is written all throughout here, and we'll get this. Okay, so we'll go for the next problem. So it is required to have correlated bivariate random variables u and v such that mu u is equal to 0, mean of u is equal to 0, mean of v is equal to 0, variance of the u is 7, variance of v is 1, then the covariance of u and v, covariance of u and v is 0.03. Specify uncorrelated random variables x and y and an angle theta that when used in the transformation 3.53 and 3.54 will produce the desired u and v. Okay, desired u and v. So we are given with the value of sigma u and sigma y is equal to 0 here, and covariance corresponding to the rho of uv, which is given here, and the sigma u, sigma v, that is root of this and root of this, that will give us 0.7937. Then the value of theta in the from 3.62, that will give us the value which is 0.7407. Let us see what is 3.62, right? Yes, here tan 2 theta is equal to 2 covariance of uv divided by sigma u square minus sigma v square. Tan 2 theta is equal to 2 covariance of sigma uv divided by sigma u minus sigma v square. That is 2 into whatever is given, I think might be 0.8 or whatever it is, right? Divided by 7 minus 1. So, sorry, 0.3, 2 into 0.3 divided by 7 minus 1. That will give us the value which in degrees as this. Okay, you have to put it in degrees. The calculation tan 2 theta formula is equal to 2 covariance of uv divided by sigma u square minus sigma v square. So 2 into 0.3 divided by 7 minus 1. These are the two quantities which are given. Then you can find, 2 theta is equal to tan inverse of this quantity, but set it in the, degrees, so that you'll get it. Or otherwise you set it in radians and write it as radians. Okay. Okay, once you have found theta, you can find the cos theta and the sin theta corresponding to that. And then from the 3.59 and 60, to 3.59 and 60, which is the equation given over here. 59 and 60. This is the two equations. Sigma x square is equal to cos square theta, sigma u square plus 2 sin theta cos theta, covariance of uv plus sin square theta sigma y square. Okay, just substitute the values here. Cos square theta we have found, sigma u square, it is 7. 2 sin theta cos theta again we have found. Covariance of uv is 0.3. Sin square theta we have found, and sigma y square is 1. Substitute all that and we'll get it. Similarly, sigma y square. Okay, these are the formulas. Okay. So thus we can find the solution for sigma x square and the sigma y square. Okay. So let us go for the next problem. So here you have verified that E of Z1 equal to 0 or E of Z2 equal to 0 as stipulated in 3.68 using the bivariate PDF of 3.63. Okay. So whatever is there in 3.63 and 3.68, those to be considered. And if you consider the 3.17 using the 3.17 in the 3.63, then we will get correspondingly that. So let us see the 3.63. 3.63 is here. Okay, 3.63 is here. So within this, we need to, use this over here and try to substitute in that and get the value there, right? We'll get E of Z1 is equal to integral of minus infinity, infinity, Z1, integral of minus infinity, infinity, Z1, Z2, Z1, Z2, dZ1, dZ2, okay? This quantity we are going to get, and this quantity is nothing but f of z1 dz1. This quantity is f of z1 dz1 using the 3.17. So 3.17 is, here. 3.17 is here. This quantity fx x of this quantity 3.17, and that is what he might be using there. Okay, using the 3.17, you'll get this quantity. Then using 3.65 and 2.54, okay, then you'll get this equal to 0. So in a similar process, 3.65 we can just see. 3.65 we can just see over here, which is there in these slides also. Yes, this quantity f of z1 equal to 1 by root of 2 pi e to the power of minus z1 squared by 2, right? And the 2.54, okay, within this f of z1 you can substitute in the 3.6. Using 3.65 means that the 3.65 value, which is this quantity f of z1, that is this, has to be substituted in the formula which is above in this. Okay, in this, if you substitute that, then we will see that using 2.54, which is nothing but what we will get is the thing which corresponds to the 2.54, right? This quantity only you'll get, and that turns out to be 0. So in the same way, we need to, what you call, consider for the y also. That means if you, again, for x or for z or for y, whatever is the variable, this quantity should turn out to be 0 over here. And that is to be used in the next one also to get the solution. Okay, for E of z equal to 0. So then we will go for the next problem, which is 34. Verify the convolution integral in 3.84 using the information given in the figure 3.10, and by first integrating y from minus infinity to plus infinity. Okay, so the convolution integral in 3.84 is this. F w is equal to minus infinity to infinity f y f of x w minus y dy. This is the convolution integral, right? And for this convolution integral, we can try to write over here as f of w is equal to p of x plus y less than w. This quantity has to be written. And that will be minus infinity to infinity, minus infinity to w minus y f of x, y x comma y dx and dy. So if you assume the independence, then you can separate this two quantities, that is this is equal to f of x and multiplied by f of y. Then you can separate them out, right? And then you can find the PDF, which is the differential of the CDF. Okay, then naturally you are differentiating with respect to w. Then that means that this what you call integral will go, and we are left with just this quantity, and that quantity will be, because it is with respect to w, now this x will be replaced by the w minus y over here, this quantity remaining as it is. Now this is the one which is getting differentiated. If you differentiate this, right, if you differentiate and integrate, differentiate and then integrate, what you have will get cancelled, but the limits of this will no more be x, but it will be the whatever is there over here, which is w minus y dy. So thus we will get this quantity over here, right? So very simple, not a complicated thing. It is just that we'll get FWW is equal to this quantity. So for whatever is there in the figure, which is 3.10. So let us see the 3.10 figure. Yes. So this is the 3.10 figure over here, right? So corresponding to this, we have the equation, which is this, right? This is x plus y greater than w. So correspondingly, we will have the quantity also here in the same way. F of w is equal to p of x plus y less than or equal to w. So that is minus infinity to w minus y f of x y x of x comma y dx dy, and assuming the independence, that is independent just means this can be separated into two parts, f of x and f of x of y multiplied together. That will be the joint value which is written over here, and hence we are just separating them out. And if you differentiate this CDF, you'll get the PDF. And differentiating, no, see, this is differentiating with respect to W. W is there only here, W is not there here. So therefore, this quantity will remain as it is. Only you are trying to differentiate this because W is there here. And that if you would have, differentiate and integrate, then f of x will just turn out to be f of x of W minus Y. And this is nothing but the correlation. Okay, that is nothing but the correlation.